So in example 2, we are asked to find the derivative, or dy dx, for this logarithmic problem, and this actually tells us to use our logarithmic properties first. Oftentimes you will not be told to use your properties. You kind of have to get used to recognizing that on your own. So in this case, you're taking the natural log of a quotient that has an exponent. So to simplify this, before I even start taking the derivative, I'm actually going to move this down in front. So this is y is equal to 4 times the natural log of our quotient here. Okay? And this 4 actually goes to everything. So when you have a quotient based on our rules, it is the natural log of the top minus the natural log of the bottom. But remember, this 4 was the power for everything. So that means when I expand this even more into a subtraction problem, each one has to have a coefficient of 4. So essentially what you have is something more like this. Okay, that 4 belongs everywhere. So then I'm just going to rewrite this using my properties as 4 natural log of the quantity of x minus 1 minus 4 natural log of the quantity of x plus 1. Okay, this to me does not look as intimidating because a 4 is just a coefficient, right? So it's just going to be hanging out with that problem the whole time. When I take the derivative of the natural log of x minus 1, it's just 1 over x minus 1 times, what's the derivative of x minus 1? 1. Okay, that's kind of easy, right? So dy dx is equal to, let's just leave the 4. I'm just writing everything out. I know that you guys can do some of this stuff in your head, but I just want you to see where stuff's coming from. The derivative of this part right here is based on the rule. So this is going to be times 1 over x minus 1 times the derivative of x minus 1, which you guys just told me is 1. Okay, typically you don't write that, but I'm just writing it all out. Okay? Then it's minus, someone tell me the derivative, each part. So do I leave the 4? Yes, I leave the 4, just like before. Times, what's the derivative of this part? What's the derivative of what I underline in blue? Nice, 1 over x plus 1 times, now what I highlighted in blue. Yes, 1. Yes? I haven't, 1 from the exponent. No, I didn't, up here, I hadn't even taken the derivative. All I was doing was expanding. I haven't even taken the derivative yet. So what I was doing was using my properties of logs to expand to make it easier for me to take the derivative. Do you see? Because if I left it like this, this would be 4 times the natural log of x minus 1 over x plus 1 to the 3rd power times 1 over this craziness here, which becomes a complex fraction, times the quotient rule of this. Whereas now all I have to do is take the derivative of one term and the derivative. Do you see how it made it easier? Now eventually what would happen with that craziness if I took the derivative as is, it would simplify down. So this would be an example of a multiple choice problem, which I know this is not done yet, but of a multiple choice problem where you would get the most simplest answer. And if you didn't expand using your properties, you would go probably a little bit crazy. So this is just, again, for us to take a look at these problems and recognize, okay, when can I do this? Does that make sense? Okay. So then when I simplify or I just rewrite it, essentially my derivative is just 4 over x minus 1 minus 4 over x plus 1. If I looked at my multiple choice answers and it was just one fraction, what would be the common denominator here? X plus 1, x minus 1. Okay, but I'm not asking you to do that. I'm asking you to just leave it. It's for your response. Okay, questions? Before we move to the last problem, we move to the last problem, and then you guys are going to do that one problem, and then we'll go over the answer, and then you're done. Yes, then you're done. Okay, logarithmic differentiation. Okay, this is a technique that is useful for differentiating functions that are composed of products and quotients and powers. So the issue here, which is what we were just talking about, if you have a problem that is extremely complicated, meaning I would not only have to use the product rule here, but I would have to use the chain rule multiple times to get the derivative. There is the logarithmic differentiation, which these problems don't come up a ton, but you just have to know that you can do this. So what this means is, and I'm going to write this down in steps, is that in the first step, what I'm going to do is take the natural log of both sides. And what that's going to allow me to do is use my properties of logs to expand, so I can make my problem easier. So I've got the natural log of y, because remember, what you do to one side, you have to do to the other, is equal to the natural log of the quantity of the tangent of x squared times 1 minus x cubed to the 1/2. And I rewrote these as powers because if you remember, with the properties of logs, once I expand the right-hand side, I can bring those exponents down in front, so I no longer have to use a chain rule. Does everyone see what I'm talking about? Okay, so I'm going to leave this for just a second because I want to expand this. I am not taking the derivative yet. I'm not to that point. I have to expand this side. Okay, we're going to expand. So we've got, in our second step, this is still the natural log of y is equal to. So now this is a product. Product expands to what? Addition. In addition to that, I will have a power here. So let me just do this one step at a time. You've got the natural log of the tangent of x, the quantity squared, plus the natural log of the quantity of 1 minus x cubed to the 1/2 power. I can still expand this even more to make my life a little bit easier. Because remember, if you're taking the natural log of something to a power, where does that exponent go? It jumps down in front. So then in my third step, still not taking the derivative yet, I'm still expanding again. Okay, you've got the natural log of y is equal to 2 natural log of the tangent of x plus 1/2 natural log of the quantity of 1 minus x cubed. Okay, I can't really expand anything else. This does not go to each one of these. This would have to be a multiplication or a division problem. So at this point is where I'm going to start to take the derivative. Okay, so now in step 4, we're going to take the derivative. All right. Because we are taking the derivative with respect to x, what is the derivative of the natural log of y? Well, first of all, regardless of the variable, if you're taking the natural log of a variable, how do you take the derivative? What's the rule? 1 over whatever that variable is, right? But in this case, because it's 1 over y and we're deriving with respect to x, I have to attach that dy dx on there. So this is 1 over y dy dx. Okay? Is equal to, all right, so now I need to take the derivative of all this stuff. So this is just a coefficient, so this is going to be in the top, right? And we know that when we take the derivative of a natural log, it goes to the bottom. It's 1 over whatever that term is, so it's the tangent of x. But what's the derivative of the tangent? Secant squared. I heard a lot of whispers. Secant squared. So can I write the secant squared up here? Like this? Yeah. Okay. Then it's plus, I don't know. We've got our 1/2 here. So that means I know I'm going to have a 1 in the top and a 2 in the bottom. The derivative of the natural log of 1 minus x cubed, what's the first part of the derivative? What's the derivative of the natural log of x? Remind me. 1 over x. What's my x term right now? 1 minus x cubed. So what's the derivative of the natural log of 1 minus x cubed? Just the first part of it. 1 over 1 minus x cubed, right? So we have this 1 in the top, this 2 in the bottom. So it looks like this. But then what do I have to do? Take the derivative of 1 minus x cubed. That's right. What's the derivative of 1? 0. What's the derivative of negative x cubed? Negative 3x squared. So this is negative 3x squared. So I just did it step by step. I know I can't write my answer like this. Okay, plus I still have a little bit more work to do. But before we get to that point, does everyone understand where everything came from? like how we got each piece. Okay. Let's see. So because we are looking to solve or find dy dx, okay, I can't have this in here. So that means I need to move this over here, right? So we're going to multiply. So this is my fifth step. I've got dy dx is equal to, and I'm going to simplify this too. So I've got 2 secant squared of x over the tangent of x minus 3x squared over 2 times 1 minus x cubed. And this is times y. Okay, I just want to show you something. So what we did was we moved this over. Okay, so now it's right here. But we actually know what this is. We know what y is equal to. And if we're trying to find our derivative with respect to x, typically your problem is going to be all in terms of x. Your answer. Typically, not always, but typically. If you go back up to the top, what is y equal to? Yeah. So you need to make a substitution here. So your final answer is dy dx is equal to, we've got all this that we worked so hard on. Okay, and then we're going to multiply by our original y, which is the tangent squared of x times the square root of 1 minus x cubed. Okay. So I know that it is my job to write sequentially so that you can understand. But remember, it is also my job to read your work when you're taking a test, quiz, showing your homework. Do you see how you can follow this? Regardless of the numbers. It is step by step. Some of you need to work on this, please. Like, immediately. Okay, because the sprinkle confetti work that you're showing on your test, it's going to be really rough for you to get through the rest of the year that way. Okay, does anyone have any questions on this crazy problem? No? Okay, so what I would like you to do right now, before I give you your own time and space, which I know you guys love, I'm going to pause this for right now, but you guys are going to work on this, and then we're going to go over the answer. So I'm going to give you about 3 or 4 minutes to do it. Okay, here we go. So can someone tell me the first thing that I would do here? What is involved in this problem, first of all? Yeah, I have to use the product rule. So first of all, let's just take this one piece right here. What is the derivative of the natural log of xy?
1 over xy.
Okay, so it's 1 over xy. So we know we're going to have an xy in the bottom, right?
Yeah.
So we do have to do the product rule you guys told me. So let me just do it like this. So we've got f and we've got g. What's our f? Okay, we're going to make that x. What's our g? All right, so then f prime is, whoops, it's 1. And what's g prime? Nice, dy dx. Okay, so that means if I've got f prime times g, that means this is going to be y plus f g prime. So it's x dy dx. Everybody okay? Is equal to 1. Okay, so to make this look less scary, can I just multiply this over here?
Yeah.
Okay, so then we've got y plus x dy dx is equal to xy. Now what? Subtract y. So you've got x dy dx is equal to xy minus y, and then divide by x. So essentially, we've got dy dx is equal to xy minus y over x. Is that right? Bless you. Could you factor out a y? But why? WHY. So you can tell it's there. Sure. Okay. Any questions?
Could you not use the property in the beginning?
Can you not use the property? What do you mean?
Like for ln xy, could it be ln of x plus ln of y?
Yeah.
You could do that way too. I did that and I got a different answer.
It's going to look different. Did you get a common denominator?
I got negative yx.
Let me do it. I'll do it and then I'll see. I see you.